17.1, so we're continuing dealing with triangles, but we're going to add a new theorem, and it's the triangle proportionality theorem, okay, which we're going to be able to answer our essential question once we are done. Our essential question states, when a line parallel to one side of a triangle intersects the other two sides, how does it divide those sides? Now, the actual theorem states if a line parallel, so that's EF here, to a side of a triangle, which would be BC here. Now, since we know those two lines are parallel, what that does for us is it then gives us this proportion here. Takes the top to the bottom half of that triangle, and the top of the other side to the bottom half of that triangle. One of the ways I think about this is that line that goes through the triangle, think of it as your fraction bar, and it creates a fraction. There's your top part of your fraction, bottom part, top part, and bottom part of your fraction. Now we want to do a little proof of why this is true. So given EF is parallel to BC, we want to prove our proportion there, AE over EB is equal to AF over FC. Step one, we want to show that triangle AEF is similar to triangle ABC. Because of our given EF is parallel to BC, you can conclude that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Why do we know that's true? Let's look. What is the relationship between 1 and 2? Corresponding angles. What's the relationship between 3 and 4? They're corresponding as well. So our reasoning that we can state that those are congruent is because of corresponding angles theorem. So then we know triangle AEF is similar to ABC by what? What triangle similarity do we use to prove those triangles are similar? We have angle, angle. We have, someone's already said side, side, side. And the last one is side, angle, side. Have we talked about any of the sides? No, what have we talked about? We've talked about in how many angles? 2. So what triangle similarity then would you use? Angle, angle. It is crazy hard like that. What you've talked about is what you're going to use. So if we've used 2 angles, we're probably going to use angle, angle. Okay, if you don't know anything about sides, you're not going to use side, 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 or side, angle, side. Just look at what information you know, and it's going to tell you which of the similarity theorems you're going to use. All right, now that we know they are similar, that now gives us that all the sides are proportional. So let's now work through the proportionality statements to get what we want. So I know that AB in my bigger triangle is to AE in my smaller triangle, which then means AC over here is to AF there. So just setting up that proportionality between our 2 triangles. Now, angle addition states, as we look at this, AB is made up of AE and EB. Right? That told this is made up of those 2 smaller parts. So that is also true on the other side, that AC is made up of AF plus FC so all we did is we split up our longer segment into the 2 smaller segments. And then for our third step, we can take a fraction here and you write it as two separate fractions. And AE over AE is what? What is same over same? 1. That's how we get 1 here. So AE over AE, regardless of what that measurement is still going to be 1 because it's going to be the same measure over the same measure. Well, we can do the same thing here, and we can get AF over AF plus FC over AF. So then we get 1 plus FC over AF. Subtract 1 from both sides, and we're left with FC over AF here. And then to go from here to here, we took our proportion and found the reciprocal, which we can do. If we take the reciprocal of one side, we need to do what?
Take the reciprocal of the other side.
Take the reciprocal of the other side. So FC over AF becomes AF over FC, which is exactly what we wanted to show. A little critical thinking here. On the reflect, explain how you could conclude that triangle AEF is similar to ABC without using angles 3 and 4. So as we look at our triangle here, if we just know 1 and 2, but we do not know 3 and 4, how else can we show that those two triangles are similar? Take 1 minute in your groups and discuss it. As we look at this, if we want to find another angle, what would be the easiest next angle to find? Yeah, right? We have two triangles. I have this triangle, and I have that triangle. They both have angle A in them, which means, to answer this question, we have angle 1 is congruent to angle 2, and angle A is congruent to angle A. Same, better, equals same. And so that's a big one that comes up when trying to prove that two triangles are similar, is they generally or often will have a shared angle that you need to pay attention to. All right, so let's put this into practice. So as we look at number 2, we want to find PN. I'm going to call that X. Then our line intersecting our triangle is PQ. So if I look at that, I'm going to write X is to 3 as 5 is to 2. I did this segment over that segment and this segment over that segment. Now 2 times x is 2x when we cross multiply, and then 3 times 5 is 15. Divide by 2, and x equals 15 over 2, or 7.5. Now, I always preferred to go from the shared angle in this one, but it doesn't matter if you're someone who likes to go from top to bottom, and you wrote 3 is to x, so I'm going from here to here, as 2 is to 5. As long as you keep the segments consistent, when I cross multiply, I still get 2 times x, which is 2x. I still get 3 times 5, which is 15. So it does not matter. That's that reciprocal idea that we just talked about in our proof. Okay, so it doesn't matter as long as you keep the relationship of where they stand together. All right, let's look at number 3 now. So we want to find CY. We'll call that X. Here's our dividing segment. So then we can go 9 is to what? 4. And then our other proportion would be what? 10 is to 10 is to x. Cross multiply, 4 times 10 is 40. 9 times x is 9x. Divide by 9. And x equals 40 over 9. If you want to get a decimal, you can get a decimal. It's like 4 point something. All right, using that, and I want you to try number 4 on your own there. Okay, see if you can find DG. So once you solve, you should get DG equals 30. So if I call DG x, I get 32 over 24 is equal to 40 over x. Cross multiply, and I get 32 x equals 24 times 40 is 960. Divide by 32, and x equals 30. We can use triangle proportionality theorem to find missing segments. We can also use it to prove that lines are parallel. Now, when we're looking for lines that are parallel, they're going to give us all 4 segments, and then we got to show that those proportions are correct. So as we look at 5, you'll notice that they give us all 4 segments here. So we're going to write our proportion. Here's the line that's dividing that we want to try to prove is parallel. So I'm going to write 42 is to 21 as 30 is to 15. Setting up the same proportion, but this time we don't have to solve. We're just going to simplify and check to see if that is a true statement or not. So 42 over 21 is 2. 30 over 15 is 2. 2 equals 2, so then we can state that MN is parallel to KL. All right, number 6, when I put this in here, I must have missed the measurement. So we'll say that AD is 12 centimeters and BE is 10 centimeters. Okay, I want you to try and find out if DE is parallel to AB. So that's what we want to identify. So go and work on that in your groups. We're going to start out by setting up a proportion. So I'm going to go, let's go 12 is to 20. As 10 is to 15. Now, this here may be hard to see if they are equal to each other, so we can do one of 3 things to check, and I'll show you all 3, and then you can decide which methods you like the best. I can first reduce it. So 12 over 20 reduces to 3 over 5, and 10 over 15 reduces to 2 over 3. Once it's fully reduced, they should be the same. Is 3/5 and 2/3 the same? No. The other thing we can do is we can actually divide it and get decimals. So 12 divided by 20 is 0.6, and 10 divided by 15 is 0.67. Are those 2 equal to each other? Nope. And the other way is what we've been doing to solve. We can cross multiply. 12 times 15 is 180. 20 times 10 is 200. Is 180 equal to 200? No. So then we would state that DE is not parallel to AB. So good question, I'll explain this to number 5 because the numbers work out a little bit better. So if I put 21 over 42 and 15 over 30, I will get a different number, but I would get 1/2 is equal to 1/2. We're not worried about what the actual number is. We're just checking to see if one proportion is equal to the other. So is 1/2 still equal to 1/2? Yeah, we don't care what the number is. So that's still a true statement. All right, number 7. Now that we've done all this, we have several different ways we can write out similarity statements. Hey, first one is with triangles. So that's what we've done so far. So I have my small triangle and then our bigger triangle. So I'm going to write those proportions out. So we have AX would be over what? AB. And that would be equal to what? What would be our next proportion? AY over AC. And since we're doing a triangle, we can write all three of them in a row. Our last proportion would be XY is over BC. Good, so that's one proportion. Now there's 3 of them in there depending on what we need, because we can say AX, we can do those first 2, we can go first and third, or you can do second and third depending on what you need. You don't need all 3 of them, you just need 2 of them to solve something. And then the other one is based on what we did today, and that would be AX is to XB, and AY is to YC. So that's the one today where we split our triangle in its 2 proportions. Now, one thing we have to pay attention to, for that to be true, or to be able to use that, what needs to be true in our triangle? For this statement to be true, AX over XB is equal to AY over YC, we have to know that XY is parallel to BC, or be trying to prove that. All right. Now, our essential question to finish. When a line parallel to one side of a triangle intersects the other 2 sides, how does it divide those sides? And you should be able to answer that with one word. Look at your theorem. Our theorem is triangle proportionality theorem. Everything we've set up when we drew that line is it cuts the 2 sides proportionally.